Let me show you how we eliminated memory cards and why our backup is just a few megabytes for all our videos, yet we run a full 4K workflow. We can edit anywhere, on a Mac, PC or even Linux. Hi, I'm Damon from Mercia Solutions. For decades I've been building data workflows for corporate and government bodies. We specialise in long-term data storage and management, and our average installation is over 2,000 terabytes. So you can see, managing the few hundred gigabytes we produce for each video should be quite straightforward. Let's take a look at how we do it. So starting off, you can see we've got multiple cameras. We have this camera, we even have an interactive whiteboard. Let me show you where all of the feeds come in. So what you can see on the screen here is a piece of software called VMIX, and each camera comes in as an individual feed. We can even output combined and overlaid graphics, such as you're seeing now with me in the corner with the whiteboard behind. And as you can see, the whiteboard even functions as an extra display for the computer system. So each of our cameras then has had the memory card removed and the battery removed. So what do we do instead? Well, with most cameras you can get an adapter whereby it's the size of a battery and can plug in. And you can see on this one there's a little slot that folds down. That allows me to plug the battery in, run the wire through the camera, and then through here I can actually shut the battery door. I've then actually tethered the camera for power. Secondly, the signal then we take via HDMI at the side of the camera into a capture card directly into the computer. So coming back to the PC, we can see we've got the output from all of the cameras, including the edited or the combined outputs of VMIX, stored in an individual output file. And then each of the individual feeds, the whiteboard, one camera and the other camera, are stored separately. And if we're using the NDI link, which is an additional great piece of software, we can actually use an iPhone over a wireless network and use the cameras in the iPhone through NDI to feed straight into VMIX. So this is great for doing close-up shots or overhead shots. So back on the computer here, we can see that this consumes quite a lot of disk space and also needs to be a very fast drive. And this is where the first clever bit of storage comes in. As this is using an AMD motherboard, we can actually download from AMD a piece of software called StoreMI. StoreMI allows us to actually combine multiple drives into one drive, so we can create what we call a tiered storage. So what I've actually got here is the first part of the drive is 2 gigabytes of RAM on the machine, which is incredibly fast. So that means when all of these cameras are writing at once, there's plenty of space for that to go to. From that RAM cache then, the data then moves to an NVMe drive. So on here I've got a 223 gigabyte NVMe drive. And the data moves from the RAM to that NVMe drive. And then from the NVMe drive, it moves to this 8 terabyte spinning hard disk or SATA hard drive. And you can see here, this drive then gives us an 8 terabyte of capacity. So plenty of space for storing all of the raw footage from all of these cameras simultaneously. The next part of our workflow is taking the finished video or the raw footage from VMIX and then editing it. What we actually do here is we've got a separate file server, and on the server we just create a folder and we use a number to start with and then the title of the video we're producing. As you can see here for this video, we've created 161, my storage and workflow process. And if I open the folder, you can see in here we've got various bits of B-roll graphics and details we would use. And from there, we would then literally copy raw footage straight from VMIX into this folder. By copying the footage from this main machine here to the file server, we then create a second backup of all the raw footage. We're placing a copy of all that content on another server backed up with RAID. So we've then got 2 copies of everything that's been filmed within a short space of time. That way, if the server was going to completely fail, we could go back to the raw footage on here And again, if when something went wrong, editing the raw footage on the server or vice versa, we've got 2 copies. So by copying the footage from the capture machine to the server, we create a second copy, and we're then working with a copy of the original data. The server is actually a mirrored RAID on there, which again gives us a little bit more resilience in case of a disk failure. But should we lose the server completely, we can always come back to the capture machine here, and from which we can actually take another copy of the raw footage. So for our editing, we use Davinci Resolve 17. This allows us to quickly edit, but more importantly, it detaches the actual editing information from the actual raw footage. What do I mean by this? Let me show you. We've got up a project server in effect, which runs with a database, which we're again running on a local server here. We can connect to that server, and then from here we can actually store all of the crop and edit information for the various videos we produce. So from here, if I was to actually open, say, this video, what we can see is all of the media is pointed to on the server. But equally, in here, we can actually set the various preferences, and the media location is to where media is stored. So what this means is we could actually take a copy on a NVMe drive or on a hard disk of the working folder, take that home, and that can be then plugged into a Mac or PC, and Studio can then be pointed at a drive to access the media. However, we would connect Studio back to our server, where all of the information of how many seconds in a file's cut, where it's to, would then be stored and be accessed from. So coming back to Resolve on the workstation here, we can see that the database can be backed up quite simply by pressing the backup button, and from here we can actually save a backup. And we can see from the properties of a backup I took earlier that all of our video edits fit in under 34 megabytes. Once we've then finished editing the video and everything's complete, we would take an actual copy of the folder and write this to a piece of optical media from sort of a 25 gig Blu-ray right up to 128 gig Blu-ray. We'll produce a couple of copies of that, which can then be stored off-site. The optical provides a good long-term storage strategy, and they can be easily stored in a folder and accessed in the future should they be needed to be. And again, when we run low on disk space here, we have the option to remove the files from, or the folders from the server to free up disk space, or to increase the size of the disk space. But equally, as we go, we know we've got 2 copies of all of the finished projects stored on a media permanently. Now, if this sort of technology is of interest to you, we do in the corporate world a software package that would automate moving the data from these folders and storing it onto tape or optical media. And it can actually transparently do that in the background, whereby we can create this tiered concept that we had earlier for the actual archive, whereby you're actually archiving the latest content straight away. And we can even do things like making the files read only. I will leave a link here to the video which will show you some more on this software. Thank you.